let us say this is an inclined plane which is at an angle of 30 degree with the horizontal, and we have projected a body at an angle of 15 degree with this inclined plane with the velocity of 20√2 meter per second. Let's see how easily we can do it even without rotating the x and y axis as we had just done. We are asked what is this distance, that is O to A, what is going to this distance we have to find out. So what we do is we proceed as we have been doing in our much earlier cases where we break the velocity along the x-axis, along the y-axis, where x is purely horizontal, y is purely vertical. So if we break this velocity into two components, that is, this is the velocity over here 20√2 meter per second, and our x and y axis, they are purely horizontal and purely vertical, that is this and this. This angle is 30 degree, this angle is 15 degree, so this total angle is 30 plus 15, 45 degree only. So with the horizontal, this is making angle of 45 degree. So this can be broken in two parts. One is 20√2 cos 45 degree, and this is 20√2 sin 45 degree. Cos 45 is 1 by √2, sin 45 is also 1 by √2. So 20√2 into 1 by √2, that makes 20 meter per second. So this comes out to be 20 meter per second, and this also comes out to be 20 meter per second. So this has two velocities. We can break into two components. One is the velocity this way, 20 meter per second, and this velocity is also 20 meter per second. And this is going to strike over here. We have to find what is the value of this distance up the inclined plane, SOA. We have not rotated our reference frame, we have not rotated x and y axis. We have been dealing with this as we have dealt in our earlier cases. We say, let's say its coordinates, they are x and y. X and y, they are its coordinates. So if x and y, they are coordinates, we use the equation Sx is equal to uxt plus half axt square, as we have been doing earlier. Now x-axis is like this, y-axis is like this, and we have taken upward vectors as positive, downward vectors as negative. Also, we have taken ay is equal to g in the vertical downward direction, and ax, that is purely along the x-axis horizontal, it is equal to 0. So when the body goes from here to here, it is not bothered whether there is inclined plane or not. It is still following the same kind of equation of trajectory what we had done earlier. So Sx is equal to, so when we say Sx is equal to uxt plus half axt square, Sx is what? Sx from here to here. What is the coordinate? It is x only. So x is equal to ux. Ux is what? U cos theta, that is 20 meter per second, into t plus half ax is equal to 0 into t square. The acceleration along this axis is equal to 0. So this x comes out to be 20 into t. That is equation number 1. Then we can also write the equation on the y-axis also, that is sy is equal to uyt plus half ayt square. What is displacement along y-axis when the body has gone from here to here? Initially over here, y coordinate is equal to 0. Over here, when the body reaches over here, y coordinate is y. So it has gone from this level to this level. So displacement on the y-axis is this in the upward direction, that is y only. What is uy? Uy is 20 only. In the upward direction, positive. Half ay, action on the y-axis is g in the downward direction. Let's take it as minus 10 into t square. So now we have two equations. One is this equation in terms of x and t. The second equation is also in terms of y and t. How many unknowns we have? We have x is one unknown, t is the second unknown, and y is the third unknown. We have three unknowns and we have only two equations. To find these three unknowns, we have to have minimum three equations. From where to get the third equation? Third equation is simple. If this is coordinates, if the coordinates of this point, they are x and y, it means from here to here, we are saying that this length is x. And we are saying that is from here to here, this length is y. And in this right angle triangle, certainly perpendicular base, that is y by x, is equal to what? Tan 30 degree. The value of tan 30, we know tan 30 is equal to 1 by √3. We can put the value over here. Now we have three equations in x, t and y. We can make use of these three equations to find the value of x, y and t. Once we find the value of x, y and t, so once we know the value of x and y, so this length from here to here, that is SOA, that is L, is going to be equal to under root of x square plus y square. That is, this is hypotenuse of this right angle triangle. Using this, we can find what is the value of displacement or what is the value of range up this inclined plane, and we have not even now broken this axis into any of its components. So this is also one way you can solve the questions of projectile on an inclined plane.